Hello everyone, this is Puya. We're going to continue with the inheritance video. So let's look at how the assignment operator works with the concept of inheritance. So here you can see that in the class base we have one member variable, we have a non-default constructor, and we also have an assignment operator. And in the class savings we have one extra member variable and the non-default constructor, which is calling the non-default constructor of the base in the initialization list. So here this is the calling the non-default constructor of the base class. This is calling the non-default constructor of the derived class, which consequently it's going to call the non-default constructor of the base class. So let's look at these two operations. B1 is an object of class base and S1 is an object of class savings, right? So think about it this way, that B1 has just one member variable ID, but S1 has two member variables, ID, and in addition to that it also has age as a member variable. So S1 has everything that B1 has. It also has extra age as a member variable. So it is possible to basically slice part of S1 and assign it to B1, right? Because S1 has everything that B1 needs. And look at this one here. B1 is the calling object. B1 is the one who calls the assignment operator, and B1 is an object of class base, so it's going to call this function, right? And here S1 basically is going to be a slice, and part of S1 that is needed by B1, it's going to be assigned to B1. However, for the second one, for the second operation, right, does B1 have everything that S2 needs? No, because B1 only has the ID, doesn't have age. This is not possible, right? So you can think of this, that the assignment operator is not inherited, right? And this object of class savings, it doesn't have an assignment operator to call. So this is not valid operation. It's not a valid operation. So you can assign an object of derived class to an object of base class, but you can't assign an object of base class to object of derived class. This, if you remember, like I showed you the picture, that always the base is smaller than the child, like that, than the derived object, right? So you can just basically cut part of the derived object and assign it to base, but you can't expand the base, right? And the assignment operator is not inherited in this case. So this is called like assigning an object of the child class to a parent object. It's called slicing. You basically you only take part of this object and assign it to B. Okay, so this is what's happening here. However, the other operation leads to compiler error. It's not possible. You can't assign an object of base class to an object of derived class. So I wanted to mention this here. Similarly, and we're gonna talk about this in the video about polymorphism, but similarly, like look at here, we have an object of class base, an object of class savings. This is possible. You can assign an object of the derived class to base class. Okay, now look at this one. We have base star BPTR. What does this mean? It means BPTR is a pointer that's going to point to an object of class base. savings star SPTR. It means SPTR is a pointer that's going to point to an object of class savings. Okay, now an object of class saving can can act as an object of class base because it has everything that object of class base does, right? So it can assign BPTR to point to S. This is possible. However, you have to know that when we do this, BPTR is still a base star. Like it's a pointer of class base. It's a pointer pointing to an object of class base. So using BPTR, you cannot have access to extra member variables that are only inside class savings. You can have access to ID and balance and this print function, but you can't have access to age, ATM, and the other print function. So this is very important to note here. Similarly, we also have a reference variable. So base ampersand bref. You can also assign S to this bref. This is also possible, but again, you have to know that this bref, it's gonna be a base ampersand variable. It's a reference variable of class base. So using this variable bref, you can only have access to base members, not the savings members, right? So you can have access to ID and balance of S, or you can call the print function here, but you can't have access to age and ATM. In the next video, when we talk about polymorphism, we're going to talk more about this concept, but here just wanted to show you that this is possible, this is also possible, but this is not valid, this is not valid. And similarly, if you have savings ampersand sref equal to b, that's not going to be valid. Okay. How can we make this operation legal? So we can actually overload the assignment operator in the derived class. So look at this one. So here we just say that we have an assignment operator object, that it can take an object of class base, takes it by reference, right, and also returns by reference an object of class savings. So if we define this, this is gonna be okay, this is gonna be allowed, right? So this is now we can do this. This is not invalid anymore, it is valid now. Moreover, you can also in the derived class, right, you can just basically implement the assignment operator for the derived class like this. So you basically say that, okay, just like here, this is the assignment operator. It takes a derived object. It's gonna return a derived object by reference, and it's gonna call the base assignment operator. Okay, base assignment operator, and it's gonna handle assigning all the common elements between base and derived to the calling object. This line handles the assignment of the inherited member variables by calling the base class assignment operator. The remaining code would assign the member variables introduced in the derived class, right? So this one would assign all the member variables that are defined in the base, and then later on you can say, for example, this arrow age is equal to age, this arrow ATM is equal to ATM, and so on, or RHS.age or RHS.ATM. Okay, so here you can also call the assignment operator of the base class. Okay. Another way of doing this is adding this line into your derived class, saying that okay, we can use the base assignment operator, which is, of course, it's going to only assign the member variables of the base. But if you do that, then this is going to be okay, this is going to be legal. That's fine. It's going to only assign the ID and balance of B1 to ID and balance of S2. So that's what's happening here. So this is another way of making this operation valid. If a copy constructor is not defined in a derived class, C++ will generate a default copy constructor. So we have seen that before. So like some member functions, if you don't define them, the compiler would generate one, like a default constructor, destructor, assignment operator, copy constructor. But we have to remember that this only does shallow copying. So if we have dynamic variables or pointers, this is not gonna do what we expect to be done, right? So like you have to be very careful if you have pointers and dynamic variables, like the copy constructor that the compiler generates for us only takes care of shallow copying, not deep copying. If you want to implement the derived class copy constructor, it's basically can be done like this, and you can also call the copy constructor of the base class in the initialization list. Okay, so you can invoke the base class copy constructor in the initialization list. Okay, so that's basically it just like initializes the member variables that are inherited from the base, and the rest of them can be done inside the copy constructor or in the rest of the initialization list. This is an example of a copy constructor. This also like mentioned like about slicing one more time, so like that's like what I covered before. Now these three examples and the one in the next page are like good to know. So look at this example. So class D doesn't have any member functions in it, like I commented out everything, right? So in this case, instantiating an object D1 of class D, right? So it goes here. There's a default constructor in class D generated by the compiler. That one is gonna call the default constructor of the class base. So that's why like here we see this one. Okay, and the same thing here, like we have here, like is to say like D2 is instantiating by copying D1 into it. So this is going to call the copy constructor, which is going to be generated, and this one is going to call the copy constructor of the base class. Okay, so this is what's happening here. That's why it's called like printing C copy constructor. Now let's look at this one. So here we have a base default constructor. We also have a copy constructor for the derived class. Similarly, for the base class, we have a default constructor and a copy constructor. When we say D1, instantiating D1 as an object of class D, it's going to call the default constructor of class D, but before going inside it, it's going to call the default constructor of C. So it's going to print C default constructor. Once this is done, it's going to come and write down print D default constructor. So that's what's happening in these two lines. Then in the next line we have D2 is equal to D1. So now this is going to call the default it's going to call the copy constructor of the class D. So it's going to call this one, right? In the initialization list we don't have anything, right? So when we don't have anything, this is going to call the default constructor of the class C, not the copy constructor, but it's gonna call the default constructor of class C. Okay, so that's why it says C default constructor. Once this is done, then it's gonna return, and then it's gonna write down the copy constructor. Now here, like the only difference is that like here in the initialization list of the copy constructor for class D, we are explicitly calling the copy constructor of class C. So the only difference between these two is now like the first two lines are the same. It's gonna call the C default constructor, then D default constructor. Then over here it goes here, and now we are calling the copy constructor of class C. It's gonna go here, it's gonna write C copy constructor and then D copy constructor. So these are like some very details that it's good to know. In this one, when we don't have a like we don't have a copy constructor explicitly here, so like here like we have some derived class C, so this is gonna call the default constructor of the derived class. We don't have it, like it's gonna generate it, and this one it's gonna call the copy constructor of the base class, so it's gonna print constructor. Then over here again, which is it's gonna call the copy constructor of class D. We don't have it, of this class, of the derived class. We don't have it. It's gonna create one, and this by default it's gonna call the copy constructor of class base, which is like named some class, right? So that's why like nothing is printed here. Okay, but if you write your own copy constructor, if you don't have an initialization list, it's gonna call the default constructor. If you want to call the copy constructor, you have to mention that in the initialization list. So this is something to note. This is an example for you to solve. So like maybe you can just like use inheritance to do this example. One thing that's only for your information, we also have the concept of multiple inheritance. I'm not going to talk about it much because it's very messy, and like most programmers don't try to avoid it. This is like when two parents are basically superclass for a subclass, right? Two parent classes are superclass for a child class. So this child class would inherit everything from this class, also inherits everything from this class. Okay, it gets messy, like because you can see that like these two might have the same member variable, so it's gonna get very messy, right? So this is like why multiple inheritance is not very popular, but you can see an example of it here. So you can go through it yourself, but like this is only for your information. I'm not gonna focus on it, but this is possible, like to derive one child class from two parents, right? So this is called multiple inheritance. Okay, and like if like you have like if you have like variables or functions with the same name in these parents, you have to specify them, you have to distinguish them using the scope resolution operator with the name of the class, with the name of the parent class. You can see that here. One thing I wanted to mention here is like you see that like here the inheritance access mode is not provided, so by default it's going to be private. For classes, the default inheritance access mode is private. For structures, it is public. Okay, if D is publicly inherited from B, all the protected and public members in B become private members. Sorry, if D is, this is wrong. If D is privately inherited from B, all the protected and public members in B become private members in D. Okay, public inheritance means that D is a B, right? So like any object of the derived class is basically an object of base class. But private inheritance means that like you're implementing a class in terms of another class. Inheriting D from B means you want to take advantage of some of the features in B, but this is not going to be exactly, this object is not exactly an object of class base, because there's no conceptual connection between B and D. So that's the difference between public inheritance and private inheritance. We talked about it earlier. But if you don't have the inheritance access mode, this is like private, like it's by default it's going to be private inheritance. One other thing I wanted to mention is that having the same name for member variables in the base and the derived class is not an error, it's just like a very bad practice. So you can see here that class B is derived from class A. We have a member variable called x in A. We also have a member variable, an additional member variable x in B, right? So now if you want to access x, this is going to be the x from A, x from B, right? So this is like similar to redefining a function. If you don't specify like anything, it means like x from B. And if you want to use the x that is inherited from class A, you have to use the scope resolution operator. This page and the next page, it's a very good practice for you guys. So it's asking you to make some modification to the code that's given here. It's a good practice that I want you to do. One thing about static member variables is that if the base class has a static member variable, okay, so this member variable is going to be shared by the derived class as well. So look at this one. So we have a member variable, a static member variable total, which is initialized as 0. Okay, and total basically keeps track of the number of objects instantiated. It's initialized as 0, and you can see that at any constructor it is incremented. So here at this constructor and this constructor. So when we have some class A, total becomes 1. Some class B, what's going to happen in some class B? It's going to become 2. So it was 1, 2. What's going to happen here? So it's going to go here, but the constructor, the default constructor for the derived class, it's going to call the base constructor. So total becomes 3, and then finally becomes 4. And A, B, C would have the same static member, or would share the same static member variable. So both the derived and the base, and like all the derived classes and the base would share the same static member variable. This is for your information. This is just like a question that one student once asked me, like what's the difference between non-empty and empty projects. So this is not related to today's topic, so I'm gonna skip it. Again, like one thing that it was asked from me, so like I'm answering it here. So in industrial and practical projects, we want to organize the C++ projects so that each class is going to be written separately, because in real size programs we're going to have lots of classes, so we want to do separate compiling. So what's happening here is, like, let's say that if we have a class cat, right, so each class would have 2 separate files. One of them is going to be CPP, one of it is H. In the header file, we declare the class, right? So like it's the declaration of the class, declaration of all the member variables and member functions. And in the CPP file, we include the header file and we define the member functions. One thing that we want to do, we want to make sure that in the same project, this class is only defined once. So this is the old format. So like we want to make sure that this declaration, class declaration, is only done once. So usually we have if not defined, and like here, like by the convention is to use the same name of the class underscore capital H, everything capital. Some people put the second underscore, some people skip it. It can be any name, but this is the convention that we have. If not defined, define it, and this is end if, right? If not defined, define it, right? And then end if. But the problem is that like everybody who works on the same project has to follow the same format. In the newer versions, I'm not sure if I have it. Yeah, in the newer versions, we just like use this one instead. So instead of these 3 lines, we only have 1 line in the beginning that we say like pound pragma once, right? So that makes sure that this class is only defined once, right? And you have to know that like all your non-member functions is going to be in a separate CPP file where your main function is, and then you have to include all the class header files here. Okay, so this is called separate compilation. It's very recommended for huge problems. One other thing that I wanted to mention is that there is a keyword called external. If you have like multiple files in your project, right? If you define one variable in one file, let's say like a global variable in one file, and you want to use it in another file, then you just like in the other file you define it as external, so using the keyword external. So like if you write this, it means that this variable I, right, has been already defined in another file. Don't redefine it. This is the same one, so it's going to keep the same value. It's not a separate variable. Okay, so it means like this has been defined somewhere else. The same thing for functions, right? So like if you want to use a function that's defined in another file, you can use the external keyword to do that. Another practice question for you guys, so you can look at this and try to implement this problem. So like the class declaration is given, you are asked to expand it and define all the functions, member functions. Thank you so much. This was the end of the inheritance fund.